So here's a related rate problem. Okay, so let theta in radians be an acute angle in the right angle triangle, and let x and y respectively be the length of the sides adjacent to and opposite to theta. Okay, so I will draw this quickly. Okay, so 90 degrees. This is theta. So to tell me respectively adjacent and opposite. So adjacent first and then opposite. Okay. Now suppose that. So let's see what they give us now. X and y vary with time at the instant when x equals 2 and increasing at 4 units per second. So I know that x increases at 4 per second. So right away I know that dx over dt is 4 and dy over dt. So y decreasing at 1. So it's -1 because it's decreasing. What are we looking for? How fast is theta changing? So we're looking for d theta dt equals what? When? Well, when x equals to 2 and when y is equal to 2. That's my problem. Okay, that's how you set it up. Any questions at this point? This is the hardest part. Once this is done, the rest should be pretty straightforward. Okay, so we just need to find a relation between theta, x, and y, which obviously in the right triangle will be the tangent of theta is y over x. So let's do it. So tangent theta is equal to y divided by x. And now I'm going to derive both sides with respect to t. Okay, so the derivative of tangent is secant squared theta times d theta dt is equal to what here? Okay, so the derivative of y over x is going to be, of course, so dy dt over dx dt. Okay, derivative of y and then derivative of x. Is that okay? Is that okay?
Aren't we supposed to do like a quotient rule?
What?
Aren't we supposed like to do a quotient rule or something?
Yes, we're supposed to do the quotient rule here, okay?
Mm-hmm.
So you can't just say yes at everything I write. Okay, so that's not good. Okay, that's not good. Okay, I wrote it in pencil, and if you see me change from pen to pencil, it means I'm writing a mistake. Okay, so that's not good. Okay.
I didn't do that. I got lost, but
Excuse me.
I didn't actually do that. So I did it right on my paper. I just got lost when you were explaining it.
Okay, okay, good. So you weren't following. It's better that than making the mistake. Good. So let's get rid of this nonsense. And so after the quotient rule, so dy dt, so derivative of the top times the bottom minus the top times the derivative of the bottom, and all this divided by the bottom squared. Good. Now let's see what we got here. Well, x we know it's 2, y we know it's 2, dx dt we know it's 4, dy dt it's -1 we know, x we know. Oops, sorry. So d theta dt is what I'm looking for here. Okay, and I need to get my theta. I don't have my theta, they didn't give me this. What's theta? So theta we could find, right? If x equals to 2 and y equals to 2, x is 2, y is 2, then theta will be what? Right? It's an isosceles triangle. So 40, same. So this has to be 45, 45. So 45 degrees each. Okay, so basically my theta will be 45 degrees or pi over 4 radians. Okay, so pi over 4 is much better than if you write this. Okay, I'm writing this because some of you wrote this. Instead of putting pi over 4, you did, so shift pi divided by 4. So you put 0.785, 0.7853. So you put 8.79. Okay, so that's already rounding. I don't want to round. I want exact value. Okay, if possible. Okay, so especially with angles, if you make a little rounding in the angle, it has a big effect in measures sometimes, okay, depending on the radius. Okay, and so anyways, at this point, we just need to find the secant of 45 degrees squared and everything else we have. So what is the secant of pi over 4? Okay, so let's evaluate this. I'm going to go here on the side. And let's see what secant squared of pi over 4 is. So secant is 1 over cos. So 1 over cos of pi over 4 squared. Cos of pi over 4 is 1 over root 2. So it's 1 over 1/2. And so that's 2. Oops, I'm sorry, you can't see. Sorry about that. Okay, so secant squared of pi over 4 is 2. That's it. 2 times d theta dt is equal to, so this is -1 times 2 minus 2 times 4 over 2 squared. That's it. And that's what I need to evaluate. It's under 2 on the bottom here. So we get d theta dt. -2 minus 8 is -10. -10 over 8 is -5 over 4. Okay, so -5 over 4 radians per second. And yeah, I see that it's the same mistake as what we have up here. Okay, so here's another question. Okay, so let's see this optimization problem here. 28 meters of fencing to enclose a rectangle where the length is 3 times the width. X, 3x, and a square. Of course, each side measures y. Okay, what's given to us is that the total perimeter is 28 because that's the fencing that he has. So x plus 3x plus x plus 3x, this is 8x plus 4y.
So I have a question.
Yes.
They are not together?
Who says? Why should it be together? Where do you see they're together?
I just thought probably they will be
Two
like,
separate. They're separate. No, not even
okay.
together. Okay. All right, so 8x plus 4y equals 28, which could be simplified if I divide everything by 4. I'm going to get 2x plus y equals 7, and therefore y is equal to 7 minus 2x. That's given to me. Okay, that's the relation between x and y guaranteed, or else I won't have 28 as a perimeter. Now, for the comfort of the turtle, the width of the rectangular pen should be at least 1. So x is at least 1. and at most 3. So right away, I know that x is between 1 and 3. So they gave us the bounds. And find the maximum and minimum total area of the pen. Okay, so let's find the total area. So the area is equal to x times 3x, which is 3x2, plus y times y, which is y2. This is my total area. Let's express everything in terms of x by replacing y by 7 minus 2x. So 3x2 plus 7 minus 2x squared. And if you simplify this, you'll get 4x2 plus 3x2 is 7x2, then minus 14, so minus 28, and plus 49. This is what I get for the total area. Okay, so now it all becomes a very easy question to maximize and minimize this function over this interval. So this becomes a very simple optimization problem on maximizing and minimizing a function on an interval. Okay, so what do we do for this? We find the critical values by doing a prime of x equals to 0, which means that 14x minus 28 equals to 0, which means that x is equal to 2. Right? And then to find when do I have my maximum, I check at my bounds and at my critical number, the value of the area, which is this. Okay, so let's check. So a of 1, a of 2, and a of 3. Okay, so at x equals 1, so 7, 56 minus 28, I get 28 meters squared. At 2, what do I have at 2? I plug in 2 here. So 4 times 7 minus 56 plus 49, I get 21. And at 3, so 63 minus 28 times 3 plus 49, I have 28 again. There you go. So the max area is 28 meters squared, and the min area is, as you see, 21 meters squared. And I can even find the dimensions of both pens. Sorry. So why do we need the derivative to be equal to 0? Because remember, we want to maximize and minimize this function here. Okay, so I have a function like this. I have no idea what it looks like, but what I'm interested in is it's 1, 2. So at 1, at 2, and at 3. Okay, so at 1, I found that it's 28. At 3, I found that it's 28 as well. And then when I asked for the derivative to be 0, I went to check if my function has a place where the slope is 0. Understand? So I asked when is the slope equals to 0, the slope of the tangent, and I found that it happens at x equals 2. You understand? So in other words,
Yeah.
this is a value which is worth investigating. So I'm going to investigate 2. So what happens? It's a place where the slope is 0. So chances are I'm going to reach either a minimum or a maximum, depending where it is. Is that okay?
Yeah, thank you.
Okay. All right. Should we, at this point, continue with more of these, or you want to review more of the other ones? What do you think?
I think working on these is better.
These ones a bit more? Okay,
Yes.
let's do a few more. All right, here's another word problems. Okay. Let's read the question. A spotlight on the ground shines on the wall 12 meters away. A man 2 meters tall walks from the spotlight towards the wall at a speed of 1.6 meters per second. How fast is the height of his shadow on the wall changing when he is 4 meters from the wall? All right. So basically, it's good to draw. So let me see, 12 meters away, something like this. And the guy is how much? 4 meters away from the wall. So he's about here. And he has a height of 2 meters. And the wall is right here. Okay, so the light shines like this from here. So I did it. I should have done it a bit lower, but who cares? More or less. Okay. Okay, so this is the shadow goes all the way until here. Any questions on my little diagram here? Okay, so this is the light, okay, which is on the ground, 12 meters away. So all this here, this length is 12 meters. This guy is 2 meters. This is the shadow. I don't know at what rate is it changing. And this is also changing X here, which is he's moving away from the light. So he's going towards the wall. 90 degrees, 90 degrees. And they're telling you how fast is the height. So we're looking for a relation between dy dx, dy dt and dx dt. Okay, so let me write down what I know. Okay, so the man walks at a speed of 1.6 meters per second. That's my dx dt. So dx dt is 1.6 right away. Okay, meters per second. We are looking for dy dt when he is 4 meters away from the wall, basically when x is 4. Is the setup okay for you guys? Any questions? Okay, so let's find a relation between x and y. I think it's pretty easy because as you see, this small triangle here has an angle, whatever that is, at 90 degrees. And the big triangle as well has the same angle at 90 degrees. So the big triangle and the small triangle are similar. And so the sides, the corresponding sides are proportional. Okay, so.
Sir,
Yeah.
it says when he's 4 meters from the wall, not the spotlight.
Oh, thank you. Thank you. Thank you. So when x is 8, right?
Yeah.
Sorry, you're right. I didn't draw it correct. Yeah, you're right. So it should be here. Okay. Right, at least so that it makes a bit more sense. See, that's how easy it is to make a mistake. So this I don't care. Here we go. And that's the wall. Much better. So this is Y, and this is X, and this is still 2 meters. Good, thank you. Okay, so the relation between the X and the Y is simple. So X over, well, Y over 12 is the same thing as 2 over X. Okay, and which means that Y is 24 over X. And now if I find the derivative, dy dt, and the derivative of 24 over X is negative 24 over X2 times dx dt. Is that okay? No answer means, I guess, that's okay. So X is 8, dx dt is 1.6. I have everything. Okay, let's calculate this. So negative 24 over 8 squared times 1.6. And so I get so 24 divided by 64 times 1.6, I get negative 0.6 meters per second. And that's my answer. So it's changing it. Okay, at what, how fast is it changing? It's, I got negative 0.6 means that it is decreasing at that rate. Okay. Any questions?
Sir,
Yeah.
why is X is 8, not 4?
Why is, I'm sorry?
The X is 8,
Oh.
not 4.
Because I called this as 8. Because they're telling you he walks away from the spotlight at a rate of 1.6. Means the rate at which X is increasing here is 1.6 meters per second. Okay. Now here, like I made a mistake before. They're telling you that he's 4 meters away from the wall. So that means that he's 8 meters away from the light because it's 12.
Okay.
Good. Okay, let's do another one. So this seems like an optimization one. So an oil company has a refinery at point A on the bank of a straight river 1 kilometer wide. So let me draw a river 1 kilometer wide. Okay, so this is 1 kilometer. Okay, and of course this is the river. Now, it is going to run a pipe from point A to point B, P. somewhere on the opposite side of the river. So let's say point A is here. And it will run a pipe all the way to, I don't know, point P somewhere here. Situated 3 kilometers downstream. Okay, so let's do this. So 3 kilometers, so let's say about here. Okay, so this is 3 kilometers, so I'm gonna go like this. And this distance here this is 3 kilometers. Okay, so far so good. Yeah, yeah.
It's T, that is 3 kilometers.
It's what?
It's point T. It's point P and T.
Oh, sorry. You're right. So it is going to run a pipe from point A to point P somewhere on the opposite side of the river, and then straight along. Oh, okay, so this is a point here. Okay, I understand. So it's just, this is T. Not too much damage. This is point T. And so it's going to run a pipe. Let's say to point P, right? He's going to run a pipe like this from A to P. And then from P to T. Is that right? Okay. So straight along the river to a tank T situated. Okay, perfect. It cost $15,000 per kilometer to run the pipe underwater. So from here to here, and then 9,000 to run the pipe along the bank right here from here to here. What should be the distance from P to T? So we're looking for this distance here. Okay. So basically I'm going to do this. I'm going to call this X. This is 1. This is 90 degrees. And this, of course, will be 3 minus X. To minimize the total cost. So we want to minimize the total cost. Okay, so this, I could find what that is using Pythagoras theorem. So this is square root of 1 plus x2. And then I'm going to find what is my cost function. So my total cost will be, well, this distance times 15,000. So 15 times the square root of 1 plus x2 plus what it's going to cost to go here, 9,000 times 3 minus x. This is my cost function. Okay, and x is anything from, well, it could be 0 if I go straight here. So from 0 until 3 at most. There you go. So I simplified my problem into a simple minimizer function over an interval. Okay, that's it. Let's find C prime. Let's find our critical numbers as usual. So C prime of x is equal to the derivative of this is 15x over root 1 plus x2. Okay, so I did it in one shot, minus 9, and this has to be equal to 0. Okay, let's do this. So 15x is equal to 9 times the square root of 1 plus x2.
Wait, sir.
Yes?
Why is it 15x?
Why is it what?
Why is it 15x?
15?
Oh, okay.
Okay. Okay so far? And then I'm going to square both sides. 225x2 is equal to 81 times 1 plus x2. So 225 minus 81, I think, is 144. So 144 x2 is equal to 81. And so I get x is equal to 81 over 144. Square root is 9 over 12, which is 3 over 4. Okay, plus or minus. But of course, x is between 0 and 3, so I need to disregard the minus. So x is equal to 0.75. And I'm going to find out the cost at 0, 0.75, and 3, and see what's the minimum value. So C of 0, C of 0.75, and C of 3, and I'm going to see how much it's going to cost. Okay, so if x is 0, so I have 15 plus 27, I get 42. Okay, at 3, okay, it's at 0.75. So 0.75 squared plus 1 square root times 15 plus 9 times 2.25. I get 39. So this is going to cost $39,000 here. And at 3, so this will become 0. So I have 10 square root times 15. So 47.43. And so as you see, this is the minimum. Okay, so to answer the question, the minimum cost happens when x is at 0.75. So basically 0.75 away from the initial point. So basically the distance from P to T is 3 minus 0.75 is 2.25. Okay? P to T will be 2.25 kilometers.